going to have a little mini lesson on simplifying radicals. So you can go ahead and just kind of take notes in your book or in your notebook, on simplifying radicals. This shouldn't take too long, and then you'll have the rest of the time to work on the worksheet. All right. So when we simplify radicals, it is kind of like, I guess in a way, it's kind of like reducing a fraction, okay? So we're looking for like certain numbers that we can reduce or divide away from the radical, okay? So let's start out with basics, all right? So a radical is anything that's under the square root, all right? And we're only gonna be dealing with square roots. We're not gonna look at like cube roots or anything like that. So this symbol is called a radical, okay? And then this under here is called the radicand. All right, not that you really need to know all of that, but just in case you see those terms, that's what that is, okay? So now when we simplify radicals, we are going to be looking for perfect squares, all right? So I'm gonna go ahead and make a list of perfect squares. Now, technically 1 is a perfect square. It's just not one that we typically use because it doesn't really advance our thinking at all. Okay, so I'm going to start with 4. So 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and so on. Okay. Well, what makes these perfect squares? Well, what a perfect square is something that when you take the square root of it, you don't get a decimal. Okay, so let me show you what I mean. So if I have my calculator here and I take the square root of any of these, okay, so square root of 49, well, it's 7. Okay, square root of 9, well, that's 3. All right. So that's why they're called perfect squares, because you don't get like this really weird decimal at the end of it. Okay. So like 2 is not a perfect square because look what the square root of 2 is. Like you get this, like all this junk after the 1, right? So 2 is not a perfect square. Alrighty, so how did I get these? Well, this is just 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, and so on. All right, so that's how you can generate your list of perfect squares. Okay, so how does this help us simplify radicals? Well, what if I am asked to simplify, here's the first example, the square root of 75. I almost wrote 25. 75, okay? So I want to think to myself, all right, what is a perfect square that I can evenly divide out of 75? So I come over to my list. Nope, nope, nope. Yes, right? So I can break this up into 25 times 3. Now, why did I leave them underneath the radical? Well, because we're dealing with radicals, right? So if we're going to split this up, like the radical doesn't go away, it's still there. So we're going to keep it under the radical, but we can just split those up. Okay, so now I know that the square root of 25 is 5, and then all I have left over is 3. So think about that almost like it's a remainder. Remember that word remainder, like from when you divided? It's kind of like that. All right, let's try another one. How about the square root of, how about 30? All right. Well, again, just go down your list. Does 4 go into 30? 9, 16. Well, now we're getting too big, aren't we? You know what? I don't think there's a perfect square that goes into this. This is already simplified as much as it can be. Okay. All right, let's try the square root of, let's see, where's another good one? How about 80? Okay, so I want to figure out a perfect square that goes into 80. I'm looking here and I'm like, ooh, 4 goes in there, right? So if I go square root 4 times square root 20, that gives me 2 root 20. But I think I can go further, right? Because I think I can take another 4 and divide it out of 20. Okay, so I'm going to leave the 2. 20 is the same thing as 4 times 5. Okay, so I go 2 times 2 root 5. So then my final answer is 4 root 5. Now, is there a shorter way? Sure is. All right. What if you recognized that actually 16 can be divided out of 80? Okay. So if you thought, well, 16 times 5 is also 80, then you get that. Okay. So if you find the biggest perfect square, that'll, shorten things up for you a little bit. All right. Let's just try a couple more. How about the square root of 28? Okay. So if I'm looking at these, I believe I can divide a 4 out of there, right? Because 28 is the same thing as 4 times 7. So then this one simplifies to 2 root 7. So again, we're trying to take as much out of the radical as we possibly can, leave the smallest number still underneath the radical. All right, one more, and then you can have time to work on your worksheet. I know you'll get it done in class. Okay, let's do the square root of, let me think. How about the square root of 150? Let's see here. Maybe, probably not. Nope. That one does, doesn't it? I'm sorry, you can't even see my list. 25 does, right? Because 4, I don't think 4 does. And how do you know? Well, what if I go 150 divided by 4? No, that doesn't go in there. 150 divided by 9? Nope. 150 divided by 16? 150 divided by 25? Ooh, 25 and 6. That works. Okay, so 25 times 6. Well, this is 5, and then I just have square root 6. Okay. Oh, my goodness. I keep going off screen. I apologize for that. All right. So that's how you simplify radicals. Now, on your worksheet for today, it's going to ask you for 2 versions of the answer. Let me grab a worksheet here. So it's going to ask you for the approximate and for the exact. Okay, so when it asks you for the approximate, that's the decimal. All right, so let's say you were asked the square root of 8. Okay, we'll use a small number. So the approximate is just that decimal. So the square root of 8 is approximately 2.83. It's approximately 2.83. Then it's going to ask for the exact. And you're going to start to see this in chapter 2 in geometry. It's going to ask for the exact. So that's not this. That's not this decimal. The exact is this because it's exactly what? Well, we can split this up into what? 4 times 2. So then the exact, this is a 2, that's a 2. The exact is 2 root 2. All right. So those are going to be the 2 parts to your answer. And again, you're going to start to see that in chapter 2 where it maybe asks for the approximate and for the exact. So just make sure you know the difference. All right. And I will try and remind you of that as we continue to move forward. All right.